So first of all, I would like to ask how many of you are or have used Kotlin ever? Like, oh, nice, awesome. Okay, so that makes it easy. So I guess a couple of years ago, any presentation that uses Kotlin would have to do a brief introduction to Kotlin. So I'm going to skip that. So now, how many of you have used coroutines? A few. Oh, okay, this is actually a higher percentage than I expected. That's really awesome. Okay, so as being Android developers, we face some of the common challenges all the time. And there are several really good solutions to those challenges. So over the years, the community created a lot of really nice libraries that make it easier for us to be productive instead of spending a whole lot of time in the boilerplate hell. And some of the solutions have taken over and became extremely popular, and sometimes we're blinded to some of their shortcomings. And then another solution comes along, and we are all excited. So I would like to talk about one of those new solutions that came along. So my name is Bolot. I currently work at Caffeine. So until recently, I was working at Big Wrench. So one of my colleagues, Brian Gardner, is going to be talking about testing later today. So you should definitely check out his talk. All right, so what do we want when we build Android apps? So like a lot of times, we want to make the app interesting. And pretty much everything that is interesting requires async code, right? So whenever we deal with I/O, whether it is at the network or the database, local files, we have to perform an asynchronous operation. So many years ago, it used to be possible to perform networking on the main thread, so it was permissible. But what happened when you tried to do that? Like your favorite thing, right? ANR. So eventually that became completely banned. And so like in fact, I think they kept tightening that requirement. So like you could opt in to do that yourself, but now it's like you cannot perform networking on the main thread. So there are some solutions that allow us to do that async work. So async is not simple, but some solutions exist. And so here's an example, just to motivate things a little bit. So we want to load a couple of images, maybe compose them in some way, maybe do like some sort of like a background in the foreground, and we want to display that, right? So conceptually, when somebody is telling you, like, here's what we need to do, like this is how you would write the pseudocode. In fact, this is valid Kotlin. So what is the problem with this code? So if you were to write this, it wouldn't work as is, out of the box. So you could perform some of these operations in the background thread. In fact, you can run all of this in the background thread. But when you want to display the image, you still have to post the result on the main thread, right? So because to update the UI, you have to do it in the UI thread. So this is common not just to Android, but to a lot of other UI toolkits. So conceptually, this is what we want to achieve. So how do we go about achieving this? So some of the common solutions, there are many more than just this. So like we, at the dawn of Android, we used to use async task. So I can't remember the most recent time I used an async task in a production application. I definitely write these as an example of what not to do. So just a show of hands. So when was the most recent, like, did you use an async task in the last 6 months for any purpose, right? So there are a few, right? So sometimes they're useful because it is a fire and forget, very simple life cycle. You don't have to worry about cancellations and things like that, handling errors. So like it's a very simple approach. But if you try to do anything more complicated than that, things become complicated because you're not handling a lot of the situations that may arise. There are some solutions that involve various callbacks, so they hide a lot of the complexity behind the scenes. And so all we need to do is implement the callback, and the callback is going to be called on the correct thread, and the networking operations are going to be performed in the background. So like everything is wonderful. And there are, of course, things like RxJava and like Java 8 has completable futures and things like that. So let's take a look at a couple of these solutions. So if we use callbacks, you probably have seen something like this, right? So the callbacks are absolutely wonderful, but if your operations depend on the result of the previous operation, you have to chain them in some way. And so when you do this chaining, what you get is this nesting, right? So sometimes people call this the callback hell or the pyramid of doom. So if you Google that, you'll find a couple of nice images. There is somebody doing Hadoken, So that's a good way to fight that pyramid, I suppose, or maybe it's the pyramid fighting you. But well, this doesn't look that bad, right? But if you were trying to do some more complex APIs when you need to perform multiple different steps, the hell becomes a little bit more apparent. So I'm not even going to zoom in on this code. This is just some WebRTC, like you need to perform some handshakes and things like that. So in order to establish the connection, in order to satisfy the session establishment, you need to do a lot of these steps. And I simplified it. So like I removed all of the code that does actual work. This is just the boilerplate that is needed, right? So the callback hell is real, and some languages are more affected by it than others. So Java, fortunately, had one of the solutions. And of course, RxJava didn't come from, Rx concept didn't come from Java. It originated elsewhere in C#, but eventually it made the reactive programming style made its way to Android, became very popular. So we can do things like this. So in fact, this solution is better than the use of the callbacks because we can perform loading of the images at the same time. So you can zip the results, and so the two observables, so like they will load the images, and so when both of them are available, we will be able to display the images. Of course, we need to worry about the threads. So we need to make sure that we schedule on the correct thread and observe. But that one goes without saying. So once you learn RxJava, you know that this needs to be done. And of course, you can apply transformations and things like that. So it can become much more straightforward, not super complicated. Well, let's go back to our original problem. So this still looks a little bit simpler than this, right? So the sequential code is it's a little bit easier to understand. And in this simple example, the contrast may not be very high. But how do we go from here? And this is not using the coroutines at the moment. It can, but at the moment it's not using it. So how can we convert the existing sequential blocking code into the coroutines? So we need to do a couple of transformations to this code. So first, we need to introduce one way to do that is we can introduce the concept of async and await. So this is something that a lot of languages chose to do. So C#, JavaScript, Python, many other languages are using this pattern. And this is a very wonderful pattern because people have embraced it. And in fact, I was talking with somebody yesterday. So if you were introduced to the language that uses these and you're using them from day one, they are very easy to grasp, and you can become very productive using them. So this is second nature. One of the things that the Kotlin developers the language developers decided to do is take a step back and evaluate whether we wanted to introduce the async and await keywords into the language. Right? So introducing a new keyword has a lot of cost to it. Right? So the language becomes a little bit more rigid, and it is a little bit more difficult to experiment, right? And of course, the experimentation is the keyword here. So like as many of you may already know, coroutines are considered experimental in Kotlin 1.2. They're graduating to standardized out of experimental state in Kotlin 1.3, but 1.3 is not out yet, right? So for the rest of this talk, I will focus on Kotlin 1.2, and then I'll briefly mention a couple of small changes in Kotlin 1.3. So using this approach, using the approach of shifting some of the details of the coroutines elsewhere, we can use interesting composition mechanisms in order to try different coroutine styles. So here, the async and await are just functions, and I'll come back to that a little bit later. And so one of the things that changes when we introduce these, when we use these functions, when we use the async function, when we use the await function, if you look in the IDE, it will give you a little hint. So it was not entirely obvious, perhaps, on the previous screen, and sometimes that can be hidden because we could have returned the result of async from another function, so we wouldn't even see that it is, so the word async, the name of that function would not appear. But the IDE would still show us that this is a suspending function. So that what you see on the left-hand side, that little squiggly line, right? So that's the point where the coroutine can be suspended, and that's the key. So being able to suspend a coroutine means that if you perform some operation that may take a little bit longer, at that point, the coroutine dispatcher can postpone its execution, return to performing other work, and when that specific call finishes, it can resume from that point on. right? So you don't have to worry about setting up the code so that it knows when the continuation needs to happen. It just does, because the compiler does the heavy lifting. So it is worth mentioning that coroutines are not new as a concept. In fact, I think Don Knuth mentioned that the subroutines are a special case of coroutines. So they were defining the subroutines in terms of coroutines. And like you probably have heard of the term subroutine, it's just a function, right? So it's just a special kind of function. All right, so now we know which of these functions are suspending, right? And so we will look at some of the details of how that works in a bit, but let's take a look at the coroutines behind the scenes. But before we do that, one way to think about the coroutines is think about the place where the coroutine is called. So like in this case, there's async load image URL1, right? So the first line. So at this point, you can consider the rest of this code as a continuation. So this is where you might suspend, and then the rest of the code might execute at a later point. So that's hence the word continuation. And one way to implement this is by using the callbacks. And in fact, some of the implementations do that. That's like one of the simpler transformations that you can perform on the code. But the Kotlin language designers decided to go a slightly different way. So we'll go back to our our sequential code. So this is where we start. And let's convert this into the conceptual implementation of how the coroutines work in Kotlin. Like, this is just a concept. This is not exactly how the transformation is done, but this might make it easier to understand what happens. So the same code is now we're going to split it up a little bit and insert some instrumentation here. So what we want to be able to do is execute exactly the same sequence of steps, but we want to take advantage of the coroutine. So we want to be able to schedule them on the correct thread. We want to be able to suspend the execution of this coroutine while the processor may be used for some other purposes. So to achieve that, we need to create a state machine. So this grayed out code is like conceptually, all of the stuff that needs to happen behind the scenes in order for this to become possible. So we pass around an object called the continuation, and the continuation contains the information about our coroutine. So there is some context that we can carry around with us. So let's take a look at some of the details. So here's an example of one of the steps that takes place when the coroutine executes. So the continuation class just has some meta information for us, metadata. So we need to know what step in the continuation we're currently in. And in this case, it is the step number 2. Of course, that means the third step in human terms and 2 in computer science terms. So we also want to be able to hold on to some data. And that's what the context does for us. And we also want to be able to exit out of the coroutine in case an error occurs. And so this is one nice thing about this, because the coroutines can be used with a regular error and exception handling. So you can use try-catch with the coroutines. So that can simplify some of the code. And of course, in our regular code, we will try to push the exceptions out to helper functions. So that way, like, our regular flow will be a little bit cleaner. So let's take a look at the step number 2. So first, we need to check whether any errors occurred, right? And if something did occur, then we want to immediately throw that error. And otherwise, we want to perform our step. So the compose images relies on the 2 images that were loaded in the previous steps in the coroutine. So we need to get them back from the context. And so before we can display this image, so that's going to be the next step in our coroutine execution, we need to save it in the context. So we use this plus function in order to add to the existing context, right? So that it will carry the result to the next step. All right, so nobody wants to write this. And this would probably, instead of being a productive use of our time, it would end up being a very error-prone approach. It'll be very easy for us to create bugs. So we want to avoid it as much as possible. So that's something that the compiler does for us. And so if we take a look at this is just a helper function for calling that load, right? So because the load function contained, it took the continuation, but setting up the continuation is something that we can delegate to this helper function. So here's the full equivalent to the code that we ran earlier, right? And again, this is just a conceptual equivalent. So Kotlin uses the state machine, so which makes it a little bit more efficient than using callbacks, because with callbacks we have to allocate the closures, or the lambdas, and then we need to call them, and so there is a little bit extra cost. And especially if you do things like loops, then things become even more complicated. And so with the state machine, it's a little bit leaner. So the continuation that we saw on the previous slides is something that we built ourselves, but in reality, the continuation looks like this. Right, so it contains the context. So we want to be able to carry things around. We want to be able to continue from where we started. And there are a couple of important things in the context that we will see shortly. And in Kotlin 1.2, we need to implement two methods, resume and resume with exception. So as the name suggests, this is the normal, successful result of execution of the coroutine, as well as the exception, right? So in case an error occurs. In Kotlin 1.3, these are replaced with a new method called resume with, and the parameter is the result. So now you can do a success or failure. So it makes it a little bit cleaner so that you can implement the coroutine with a lambda and things like that, right? So it's going to be even better. But these remain as extension functions. So your code, the code that you write in Kotlin 1.2 is not going to break immediately. There are a couple of edge cases, but it should continue working. All right. So all of this nice and great, but most of you probably want to get something from the network. I was recently looking at the apps that I use regularly, and I realized that none of them are particularly interesting offline. So let's do some networking. And one library that probably a lot of you are using is retrofit, right? So who has not heard of retrofit? Probably nobody. Okay, excellent. So in retrofit, there are a couple of different ways you can you can use the retrofit. So like one, out of the box, you use the call interface, and you can enqueue the callbacks and respond to them. And of course, there is a Rx Java binding. And so like a lot of people use that because you can change the return type to an observable, and all of a sudden it works correctly with Rx Java. So the call adapter takes care of that. So we can implement the coroutine handling in retrofit using this approach. So we need to create the extension function, await on the call, and we will return the suspended coroutine. And then the details inside, this is where all of the magic happens, right? So we need to call the continuations resume or resume with exception, like appropriately, depending on the situation. So the suspend coroutines parameter is the continuation. So this is one way to achieve this, right? So like if you were to build this. And so this kind of like demonstrates how you could approach this for any other callback APIs that you have. So as long as you can, as long as your callback API has a way of distinguishing between success and failure, or even if it only has the success, you just need to call the resume on the continuation and you're done. There is a better way to do this. So if you are using retrofit, you will probably want to use the coroutine call adapter. So that way that happens behind the scenes for you. So to use that in your application, you will need to change the signature of the functions, right? So instead of using the call as the return type or observable, we need to change that into a deferred. So deferred is the type that Kotlin coroutines are using as the future type. And so as they described in some of their presentations and talks, the terms future were already taken, and promise was taken in the JavaScript world. And because Kotlin wants to support not just Android and JVM, but also the JavaScript and native world, they wanted to come up with a term that wouldn't conflict with any of those. And so they came up with deferred. So it just means a future. And so once we do this, the call adapter will know that instead of returning a regular call, it needs to return a deferred. So we saw the deferred earlier when we did the async await. So when we perform the async, actually what is returned is a deferred, is a future. And we'll see some of the examples of that shortly. So if we, so once we convert our API to using the deferred, we can now use these functions inside the coroutines. So we can launch a coroutine, perform the load, and this is a suspending function. So that means that some things will happen on the background thread, so the networking operations will perform, and once the result is ready, we can retrieve that, and we can perform a wait here. And of course, we need to do some error handling. So for simplicity, it's not listed here. So it is also possible for us to get the response object back. So sometimes your API may return an error object, right? So it's a JSON, so it's still considered a success as far as retrofit is concerned. So it did get the bytes back from the server, but those bytes indicate an error. So like in case that, like if that's what you want to be able to handle, then you need to wrap an additional response inside your deferred. So that will allow you to perform the checks on the response. So you still need to do a wait in order to get back the actual object from the deferred, but then you can start using the API on the response. So for example, checking whether the response was successful. And again, this is just a happy path. It shows if the response is successful and there is a body, we will be able to display it. So all of the error checking is left as an exercise to the reader. Okay, so let's go back to the async. So what is async? So async is a coroutine builder. It's just one of several. And you can create your own in case you have an application that maybe requires a slightly different scenario. So like maybe you want to control it a little bit better, you can create your own. So by default, you can see like there are several parameters to async, but we don't have to specify any because there are defaults for all of them. But the two that we care, well, actually for all except for the last one, the block. So we can rely on the async to use the default dispatcher. So like currently it uses common pool, which is just like a thread pool. But in the future, I think it is changing. So that it's not necessarily going to be the fork and join and so on. But right now, this is something that is given by default. So if you want to use something different, you can specify that. So this is the coroutine context. It determines how the coroutine is executed, including which thread it runs on. And of course, the block is the block of code, the lambda, that is going to be called in this context. So you notice the suspend keyword, right? So this is the only keyword that had to be added to Kotlin, to the language, in order to support coroutines. So the language designers wanted to keep the changes to the language to a minimum, and there is some discussion whether or not they could have made everything potentially suspending, but in the end, we have this. So any function that calls suspending functions has to be suspending. So that means that in order to be able to jump into the coroutine world, into the suspending world, we need to have this jump off point. And so that's what coroutine builders do for us. So they allow us to call suspending functions. So async is one of them. And of course, the result of async, we need to call the await. And I'm not going to show the details of how await actually works, but await itself is a suspending function, because when you are waiting on the result may not be ready, right? So that result is a deferred. And so if you actually want to use the result of that background call, you need to get that, you need to perform a wait, and it's a suspending function. All right, so there are a couple of other coroutine builders. So launch and async are very popular. So launch is something that returns a job. And actually, the deferred is also a type of a job. It's a subclass. But one of the consequences of this is that the job is something that can be canceled. So coroutines are cancelable. Like, of course, it is a cooperative cancellation, and there are a couple of little gotchas there. So the coroutines, when you cancel a coroutine, it throws the coroutine canceled exception. And if you are catching exceptions inside your coroutines, then sometimes it may catch the coroutine cancellation. So you may have to deal with that separately. So hence the comment about implementing the try-catch inside your library functions and handling that situation correctly, so that way your normal application code is not going to be caught off guard. All right, so one of the examples that people like to use to demonstrate how coroutines differ from threads is this, right? So you create a lot of coroutines. So here's 100,000 coroutines, and you perform like a simple operation inside them. Just try to print them, okay? So if you try to do this with threads, it is problematic. Your application will run out of memory. It's not even so much not being able to run this many threads. It just will run out of memory because each thread requires a couple of megabytes of RAM just to initialize. But with coroutines, you can run something like this, and each one of them is running. Like each one of them will run and after a 5-second delay. And so the delay is a suspending function. It's not a blocking function. So that thread does not get blocked. So the launch subroutine, the launch coroutine builder uses the context, and in this case, because we didn't specify any, it uses the common pool, and it only creates a limited number of threads in that pool. So there is not enough to create a separate thread for each of the coroutines. So that means that the coroutines share the existing threads. And if you use the UI context, which you want to use in the Android application to perform updates to the UI, there's only one thread in that particular context, right? So all of these coroutines will perform in the threads associated with that coroutine context. So like in this case, what will happen is the coroutines will print as dots, and they will all print, like all 100,000 of them will print after a 5-second delay. So it's not going to be 5 seconds times 100,000 delays. Okay, so let's look at, this is the example that, so you can specify the context explicitly, and so one way to do it, and so the context is the first parameter, so you don't have to specify the word context. So typically we'll see the code that just looks like this. So launch, common pool, or launch UI are probably the most common, but you may occasionally want to create your own context. So maybe you have a separate computation, a separate I/O context, and so on. All right, so what is the coroutine context? Let's take a look. So we're going back to our async await example. So this is how we solve this particular problem. And each coroutine continuation is associated with the context. There is a context associated with it. So when we did the behind the scenes, we used a map, just a regular map, to store the information. And in fact, the coroutine context kind of acts as that metadata. Like you effectively can think of it as a map. So there are several things that it can store. And there are a couple of things that are interesting. So if you try to print out things like the coroutine context, so that is something that is one of the properties available inside the continuation, you can see some interesting details. And so two details that I will point out here is the job and the interceptor. So when you print out the coroutine context, in fact, that's like you will see those two. So here's the example output. So here's what happens when we call those two async coroutine builders. So each one of them will print this. And you can see that they're both in the same common pool, because I did not specify the context to that async call. So by default, it uses the default dispatcher, which happens to be the common pool. And it also shows which job they're associated with. And you can see that those two are actually distinct jobs. And they are scheduled on two separate threads, because there is a thread pool associated with the common pool. So they may not necessarily execute on the same thread. So like if you have multiple different ones, so as thread pools typically do, like the next one available will pick up that particular job. Okay, so happy path so far. And but occasionally we have situations when things don't really work, right? So we, like, how do you deal with situations like this? And I'm not even talking about the error handling. I'm talking more about trying to load an image, and maybe for some reason, like maybe you have a spotty connection or something errored out, and you want to attempt that more than once. How do you approach this? So one way to do this is to just use the regular flow control code, right? So you can say, like, I want to try up to 3 times, and maybe initialize the retry counter, do a loop, and then keep going until either the retry counter goes down to 0 or you succeed. Right? So that's great, but it kind of pollutes our code a little bit. So one way to accomplish this is to use the composition, right? So you can use higher order functions in order to make your code significantly more readable. So we're going to push all of those details, especially considering that a situation like this may be something that you want to solve on a regular basis. You may want to create a function called retry.io. And in fact, this is something that was created by the person in charge of the coroutines in Kotlin, Roman Elizarov, in response to one of the Stack Overflow questions. Or maybe he presented that in a conference earlier and he just posted his answer. So what does the retry.io look like? Well, it is a suspending function that, well, in this case, this is a full implementation. So like I didn't omit any of the code. This contains everything. So you can specify the number of times to retry. You can specify the delays and so on. So there are some sensible defaults there. And of course, the number of times to retry in this case is the max int value, so it may not be something that you want, especially if you're trying to access the service that is down. And so wrapping your coroutine calls in the retry.io makes your code significantly cleaner. All right, so what other challenges may we face? So as Android developers, probably one of the first things that we point out in case we want to tell somebody that Android development can be complex occasionally is the activity lifecycle. So I'm not going to post a diagram. All of us memorize that. It's forever etched in our memory. Our tombstones will have the activity lifecycle diagram. But the life cycle is a very important thing to consider. And sometimes activities die. They get destroyed, whether we want it or not. And one thing to do with the coroutines is to make sure that we properly dispose of them. So if you use RxJava, you're probably familiar with the concept. So you call the dispose method and the disposable. So there's a similar dance with the coroutines. So the launch coroutine builder returns a job. So you don't have to hold on to that assignment, especially if you're just writing some demo code. But if you are using the coroutines inside an activity or a fragment, anything with a life cycle, you do want to cancel the job when this particular activity is destroyed. So here's a nice little symmetry. So in onCreate, we'll launch the coroutine, and on destroy, we cancel it. So like if you don't do this, then bad things will happen. So you may have references to the UI, to the views and things like that. The activity may be destroyed. You may be referencing something. Android is not going to be happy. And we're here to make Android happy. All right, so what are some other things you can do with the coroutines? So the channels is something that may potentially be a very useful mechanism. So if you want to be able to pass some information between two different entities, like a sender and a receiver, you can use a channel. And so this is a very simple channel. It has no buffer. It's just like when you use this channel function, it's a helper function that creates a rendezvous channel. So not particularly complicated, but this allows you to pass the information between the receiver, the sender and the receiver. And this is a very simple example. We just send some integers to the channel, and like in the background thread, in the common pool, and in the UI, maybe we display it somehow. So like in this case, it's super simplified. We just write something to the log. But in reality, you would probably want to display it on the screen. So this is one way to use the channels, very simple. So what are the channels? So the channel actually is an interface that implements both the send and the receive channel. And so you can implement those separately. So it's kind of like similar to a lot of other interfaces, right? So sometimes you want to be very explicit what you want to perform. So like in RxJava, if you are performing a web request, you probably want to return a single, not an observable, because it's fire once, right? So it makes your interfaces much cleaner. So if you only intend to receive something, then you probably want to declare it explicitly as a receive channel. But like otherwise, this channel will be both send and receive. So how can it be useful in our applications? So there are several different ways you can use the channels. I'll give a couple of simple examples. So one of them, if you wanted to change starting the activity, for example, right? So when you start the activity, you have to implement the onActivityResult method, right? So like your code is dispersed in a couple of different places. You need to keep track of the codes and things like that. But with coroutines, you can create the channel for receiving the results. And to help me with that, I defined the ActivityResult class. So there is a class called ActivityResult in the instrumentation, but that's not something that we can use. So I want to be able to return the request code, the result code, and the data to the appropriate place, right? So when so I'll start with the activity result because it's a little bit simpler conceptually. So when the activity result is returned, I want to send that, so I package that result and send it to that channel. And in order to use this, I can pass that, I can wait on the channel to receive the data. So when I'm calling the start activity for result async, I'm going to wait on the channel to give me back the data. And so here's how I would call this. So start activity of result async, I provide the request code and intent. So this is not the complete example, so like we would need to filter by the result code and so on, but conceptually you can use the channel in order to perform things like this. And you can also do things like handling the permissions, right? So because again, the permissions have this interesting state machine behind the scenes. Did you already request the permissions? Do you have the permissions for everything that you need? And you need to implement the callbacks in order to get them. And so your code becomes a little bit more complex than it needs to be. So you can simplify that with the channels, with coroutines. So another thing that you can use the channels for is to communicate between different components. So like, for example, if you have two fragments on the screen and you want to send the data between them. So of course, there are architecture components or the Jetpack. So you can use live data to communicate that. Or if you wanted to stay in the Kotlin land, you can use the channels. So again, so this means that we need to use the same channel in both the sender and the receiver, right? So that, like you can accomplish that through dependency injection, but once you have that same channel, now we can perform something like this. So this is the sender. So when we press the send button, it'll read the information from somewhere, in this case, the edit text, and pass it on to the channel. And on the receiving end, we will just loop on the information that is received from the channel. So every time we send a new text to this channel, we will get a new one, right? So we can keep updating our view. So here's the, oh yeah, so this is the same example, but like with a couple of lifecycle callbacks. So we want to, again, since we are creating a job, we want to make sure that we cancel it. Otherwise, it will keep listening on that channel forever. All right, so there is more to coroutines. So there are like actors, mutexes, and sequences. So the actors are kind of like similar to channels. They just have an associated channel in the actor. And the mutexes, you probably all have taken the operating systems course. So, and there is also something called sequences, right? So that one is a little unusual, but this is something that is frequently used as an example because like you do not necessarily need concurrency in order to take advantage of the coroutines. In fact, in some other languages like Python, coroutines evolved out of the generators, right? So the yield function here is a keyword in Python. In the earlier versions of Python, that was the primary use. So you can create an infinite sequence, in this case Fibonacci. So you see the while true loop, right? It will never stop. if you so choose to iterate through all of the numbers until you eventually hit the int max value. But with generators, one really neat thing is that when you can stop them. So like in this case, we are taking only the first 5 Fibonacci numbers, and then we perform some operation with them. And so we don't need to explicitly pass the limit to this function. So we don't need to say Fibonacci the first 5, right? So this is just a very simple implementation. We know what the algorithm is for generating the Fibonacci sequence, and so we just use this without having to worry about how many we need to display, right? So anyway, so this is not something that we probably do a lot unless you're doing one of those websites where you're trying to learn a new language. Occasionally they'll give you problems like this so that you become more comfortable. All right, so Kotlin 1.3 is the first version of Kotlin where the coroutines will no longer be experimental. So currently, if you try to use them in your code, the IDE will give you a warning that they are experimental, you have to be careful. But what that means is it doesn't mean that you can't use them in your applications. And in fact, the coroutines designer said that like they're production ready. They are using them actively all over the place. So what it does mean is that occasionally things may change. The API may change a little bit. And like you will see that shortly. So when 1.3 is finalized, a couple of things will change. There are a few improvements. So one of the results is the build sequence and build iterator now graduate to the Kotlin sequences package. So now the coroutines are considered just another feature of the language. It's not an experimental add-on. Simplified continuation is something that I alluded to earlier that is potentially going to make a lot of APIs significantly cleaner. And there are a couple of other fixes to the language, so being able to use the function references and to be able to serialize coroutines. So serializing coroutines may not be something that we have to deal with a lot in the Android applications. Well, maybe occasionally if we have to deal with activities potentially being destroyed, like when the application is in the background. But it is something that is extremely useful on the back end. So like on the server applications, you may want to serialize the coroutine, save it in the database, and kind of continue that simplified processing of the user forms. Well, so that's all I have to present on the coroutines. So I'll be happy to either take the questions here or I'll hang around later. So I'll be happy to discuss the coroutines. And there is another talk on coroutines tomorrow. I forget exactly what time, so definitely check it out. So that talk has the title coroutines in it, but there are a couple of other talks that will touch on coroutines as the more advanced Kotlin features. So if this is something that you have not started using yet, definitely take a look. All right, thank you.